since now we have achieved this form of the series, what we just need to do is to find a way on how we can separate the denominator and allocate one part to this bracket and another part to this bracket here. So let's find a way on how we can separate 2kn squared. Now look, 2kn can be written as 2kn multiplied by 2kn. So this whole thing here is still the same as 2kn squared. 2kn multiplied by 2kn is the same as 2kn squared. So we are going to allocate this part, this first part, to one of the two brackets, and this other part to one of the other bracket. Now we have to be very careful on how we are going to allocate. We have to be very careful and very diligent on how we are going to pick. So look, the first bracket has 2kn. Instead of allocating kn, we are going to allocate 2kn. So that it's going to cancel with that 2kn. We are going to do likewise for this. So this is how it's going to turn out to be in the next step. We are going to write what we have, 2kn plus 1 over 2kn. Then this is multiplying by kn minus 1 over kn. All of this is raised to the power n. Now, we can divide 2kn by 2kn and 1 by 2kn. We are going to divide kn divided by kn and 1, negative 1 divided by what? Kn. Because this denominator can divide through that and can divide through this. So we're going to write the limit as n approaches infinite for 1 plus 1 over 2kn multiplied by 1 minus 1 over kn to the power what? To the power n. What you can do for you to observe this, to obtain this, you just have to divide this divided by kn, everything divided by kn, and for this side you just have to divide everything divided by 2kn. You are going to land yourself here. Now we can distribute this n to this boy and this other boy. So what we are going to get, it is 1 plus 1 over 2kn to the power n multiplied as the limit, and we are also distributing the limit of 1 minus 1 over kn to the power what? To the power n. Now remember what we did at the start of the video. This looks like a familiar guy. So it is 1 plus 1 over n. We can try to ignore the 2k. 1 plus 1 over n is the same as what? Exponent. Now, that exponent is going to be powered by this guy which is here, which is just what? 1 over 2kn, 2k, then multiplied. We're going to multiply. Let's try to observe what we have. This is the same as just 1 minus 1 over n raised to the power n as n approaches what? Infinity. This is just the same as 1 over this boy. Now, this guy has to be powered by what? 1 over k. This will be 1 over k. Let's try to rewrite this, what we are going to have. What we are going to have is 1 over 2k when we take this to the numerator by dividing everything by exponent 1 over k. It's going to be this with a minus now being inverse. So this is what we are going to have. Now, how do we deal with this situation? Since the bases are the same and the powers are different, even though, yeah, let's just say the bases are the same. When the bases are the same, we add the powers. So it's the same as saying exponent 1 over 2k plus negative 1 over k. When the bases are the same and they are multiplying, you add the power. Now, what is 1 over 2k minus 1 over k? This is just the same as half minus 1. which is exponent to the power negative 1 over 2k. Now this is the answer we have. This is the answer we have found after using the root test. Now remember, the root test says limit as n approaches infinite of a7, this boy, if this guy is less than 1, it converges. Converges absolutely. And if it's greater than 1, it diverges. If it's equal to 1, then it's inconclusive. So we have to find conditions how we are going to make this boy to be less than what? Less than 1. Now we are going to be testing for values. We are going to be testing for values. This is how I like to do it. I'll put 0. Then I'll say going this, we are going to positive value. Going this side, we are going to what? Negative value. Then I'm going to pick any numbers. I'm going to pick -1 and -2. Then for this side, I'm going to pick 1 and 2. Now, how we are going to do it is, I'm going to be plugging 1. I'll start by plugging k for 1 and k for 2, and I'll see how it is going to behave. Either it will be greater than 1 or less than 1. Then I'll come and do the same for this side. So let's start. So if I plug in 1 for k, I'm going to have exponent raised to the power -1 over 2. Now if it's 1, k is equal to 1. This is just going to be exponent raised to the power -1 over 2. And the answer I'm getting is 0.06. If I plug in 1 there, I'm going to get 0.606. So let me try to plug in 2. So I'm going to have exponent raised to the power 1 over 4. 1 over 4. So what I'm getting is 0.77. For this side, I've seen. Now, I have to see for this side. What if I plug in -1? I'm going to have exponent raised to the power -half. What I'm getting is raised to the power half instead of -half. Because if I plug in -1, it's going to make this thing positive. If I plug in -half for k and -1 for k, I'm going to get 1 over 2 positive. So exponent 1 over 2 is giving me 1.65. If I plug in -2, I'm going to get 1/4 positive. So e raised to 1/4, it is giving me 1.28. Now let's observe. When we go to the positive side, when k is approaching the positive side, it is less than what? It's less than 1. It's 0.6, 0.7. But if I are plugging in negative values, it is 1 point. So it is even greater than 1. But what do you really want to achieve? We wanted to achieve conditions where this will be less than 1. So we can clearly see that when we are plugging in positive figures, our answer is less than 1. So for the conditions for this series to be absolutely convergent, it has to be when k is greater than 0, meaning when we are plugging in positive terms. These are the conditions which are going to make that series, the actual series which we are looking at, to be absolutely convergent. Thank you for watching. We hope on seeing you back. If you haven't subscribed yet, hit that subscribe button so that you don't miss out on future academic videos. Thank you for watching.